Hi, I'm Philip, and in this video I will show you how I designed the protective case for the Einscan Rigil using Quicksurface Pro. So as you can see, this is the final case, and yeah, I designed all three of these parts within Quicksurface. Initially, I did some like post finishing or after finishing in Fusion 360. Mainly due to me being lazy and at some points like not doing the proper best practice, I would say. So I simply fixed it up later in Fusion because I knew that I won't go above the, or I won't go over the design again. But now let's first delete these final parts and let's look at how I created them. So we're currently in the latest version of Quicksurface Pro. The approaches that I'm showing you here, they only will work in the Pro version. So keep this in mind. In the regular version, it won't work because like the CAD functionality or the advanced surface combination, surface trimming, copying CAD parts doesn't work in the light or the regular version. So to start with, I'm here at the beginning. And I have a 3D scan of the Einscan Rigil. This is scanned actually with the Einscan Rocket. And I have two versions. I have the regular version, the low poly version. The low poly version was just me using it in Fusion because Fusion can't handle these like very big scan data quickly. And to create the low poly version, I just duplicated the scan data, and then in scan data, I used the reduce polygon option to like go to 25%, or I guess I even went lower. And as you can see, I reduced it by 25% to 260,000 triangles, and I'm still at 100% tolerance within 0.05 millimeters. One other point that I got asked a few times is how do you create symmetry planes? Because after loading in the scan data and also a scan of the protective case that comes with the Rigil for transport, and I want my design to still somehow fit in the case, like a small disclaimer. It fits in the case with the printed design from TPU, but you have to force it in a bit. But after a few insertions, the case will, or the foam of the case will adapt to the new shape and the slightly larger size, so it will actually get easier. The first step is aligning. Aligning means if you like get the scan from the software directly, from the scanner software, it isn't aligned to the coordinate system, so to the X, Y, and Z axis you may well know from traditional CD design. But as you can see here, it is perfectly aligned. I did this by basically creating multiple plates based on the scanner. Like this, these are the three additional planes used for the case, for the line of the case. And then you can align it to the coordinate system. All of these functionality is basically situated within the prepare scan functionality, or the prepare scan workflow, I would better call it. And I won't go over the whole process because I already covered it in a few other videos. But maybe let's look at how to create a symmetry plane. This may be one of the points that's still a bit unclear. So it's basically construct symmetry plane, and you have to select scan data. So I selected the Einscan Rigil, you can see here. And in the first draft, you have this marker and you draw a rough estimation of the plane. If your part is very symmetrical, like the Rigil is, you can most likely stop here and just click on the rebuild button, and the software will automatically try creating a symmetry plane. If it isn't too symmetric, I would call it, and it very much helps. Like, so if I do it again, it very much helps to refine the symmetry plane further. So you can see here, I can now manually rotate it and then the rebuilding process will be a bit faster. When creating symmetry planes, you can even have an analysis of how symmetric it is. So this is at 0.05 millimeters, and as you can see, like the high spots are roughly 0.41 millimeter. For a TPU printed sleeve that will like adjust a bit to the part, this is well within the accepted tolerance I like to have. Then there will be three parts to this protective case. So you have the protection for the emitter unit, I like to call it. We have protection for the display unit, and we have protection here for the bottom of the handle that touches the table when laying the scanner down. And I just start first with creating this section, or we wanted to create this section of the part. Because if you have a look of this from the side, we have basically 4 parts of 4 faces that we need to extract. We have this drafted face, with this face, with this face, and of course we have the front face of the display. So for the first one, it's very easy. I just created a sketch, offset from the display, and just used the extract primitive rectangle tool and then filleted all the edges. And I can just now extrude it with a draft angle. When drafting, you can even analyze it. So if the draft is within the tolerance you want to achieve. Then I move on for the protection of the display. For this, I just create the intersection to the draft and offset it a bit to the middle and offset it to the outside. And the third part or third intersection will now be here at the straight part, I would like to call it, that isn't drafted, that I can just extrude as is. And then I extrude here the top sketch and create an additional plane for cutting. And now we can see here, okay, now we move to the front part. So the approach is very similar here. So just one intersection sketch or offset sketch for the first draft, also with a draft angle using the analysis function. As you can see, I'm not fully within the tolerance here I want to have, but in the end, it will be a TPU printed part. So chasing the higher tolerance or chasing everything to be in tolerance isn't my goal. So you always have to keep a bit of an you have to keep your senses when creating these kinds of parts and not getting lost in detail. So now I can start with this draft surface, and so this side or this section, and sadly it's not draftable as one intersection, so it cannot be done like this, but I have to create 4 sketches, and on each sketch I extract one line of the intersection or one side of the intersection, and now I can extrude all 4 of these sides, and in the next step use a trim operation to create now one envelope. And on this on this sleeve I can now apply dynamic, or I will call dynamic, or like the variable radius fillets to try to hit my approach here. So if I can now look at the analysis function, maybe let's go back higher to 0.05 millimeters again. This looks quite right. Again, we are TPU printing, and I will do this approach in all 4 edges. You also recognize this design approach later in further steps. But now let's again create the protection lip for the emitters in front with again a sketch and 2 offsets to the sides. I extrude it, and now I can here on the top directly fit planes. So let's hide the surface now a bit, the planes, so we can see them a bit better. Now here I was a bit lazy, I didn't want to create additional sketches, so I just directly fit surfaces by selecting a bit of the point cloud that the plane will lay on, and then fitting a plane through it. Basically, it's the extract primitive function. So for example, if I now click here the side like this, I can directly add a plane, and I can even constrain it to be like here perpendicular to the YC plane. And with the auto constraint functionality, it will do so automatically. No, I don't want to edit. So I will do this with also these sides here now. So this is a bit of the, I would call repetitive parts or small detail parts, like the power button. That is basically just a cutout later where I use the intersection and then a small offset to the side. And I moved I even copied it a bit to the offset it to the top. I then go on with adding the last surface here. So I jumped around a bit between the different parts. So it was quite late in the evening when designing. So this is like the, I would like in the beginning when I talked about making some like design flaws that I had to fix in Fusion later. And these were these parts where I just jumped around. So here I can again see trimming the 4 surfaces to get one surface, and then applying the variable fillet to the sides to match the filleting. And you can always just do a quick analysis where I can see, okay, I'm roughly within my 0.1 millimeter tolerance. Now, next step is combining all these different surfaces here, like this, to one surface that I can later thicken. But first, as you can see, we have the handle here. So I have to do like a rough cutout. For this cutout, I just create a simple sketch, a symmetric sketch of the cutout, and extrude it as a plane to both sides. And then I can thicken here this one surface now, this trimmed surface, to my wanted thickness of roughly 2.5 millimeters. So this is like my goal for protective cases, 2.5 millimeters of TPU with 2 walls and a low infill is a bit cushiony, but also quite sturdy and protective. And you could even go thicker, but then again, you have that where you create the problem of the scanner not fitting in the case anymore. So I didn't want this. With the 26 version of Quicksurface, the thickening tool even became a bit more forgiving, I would call it. So they supposedly added a new CAD core of, I think it's called Parasolid of Siemens, I guess it is. And now it is quite a potent tool at thickening. It's even more functionally than Fusion sometimes. So I had a few times the problem of using like extreme variable fillets, like multiple variable fillets combined. And then when I tried to export it and later import it in Fusion, Fusion couldn't resolve these extreme fillets. So maybe stay on the reasonable side, I would call it. And now the next step, we have like this top protective sleeve, and now the sleeve and the surface. I can just trim them down to one part. And here in the trimming, if I go in, I can even, so one of the points I initially didn't know with trimming. So currently you're seeing all the remaining surfaces or the remaining bodies. And it even shows me, okay, it's a solid body. So I can just click OK. If you accidentally trimmed one of the bodies and want to get it back, you can just switch to show the removed surfaces and click again to re-edit again. Or you can completely reset the trim theoretically. But I won't do this here. Now, as this part is finished, I can go back to the top part where basically the whole approach will be the same. I can again trim my surfaces at the variable fillets and trim again all the surfaces to one cohering surface and thicken it and trim it to create the upper sleeve. As you can see here on the side, I created the sleeve, so I have, of course, overlap, so it mechanically locks to the scanner, but it doesn't obstruct the venting fins or the vent grills. The next thing will be a small cutout here for the lower lid, because as you can see, the scanner has like this plastic rib used to protect the emitters when placing it down. The easiest way would be like to clip it off or file it down, but of course I don't want to do this on such an expensive device, so I will create a cutout instead. And for this, I just again created an intersection sketch, extruded again here the sides with a bit of I would say tinkering around to create a good shape, and I can then move to the top for the power button cutout. So initially I want the power button cutout to actually be like a 3D printed rubber button that is depressed down, and on the downside presses the original button. So as you can see here, I created like this small gap. But when printing the first prototype, I came to reason and just later deleted the whole inner part in Fusion to just have a hole. It's big enough to simply press the original button, and I'm not having any issues with TPU printing, because here the insides, you can imagine that supporting will be quite a nightmare. The next steps will be some filleting operations on the parts. So as you can see here, that's just I'm going around all the sides to create fillets, or here, also here in the power button and on my emitter cover. So this isn't too interesting, I would call it. So as you can see here, I'm doing all the filleting here within Quicksurface. And now I just have to delete the wrong part, because this is one of the points where I accidentally broke the workflow, because I mixed the different parts a bit up. In retrospective, I maybe should have created different Quicksurface projects for the single parts, so I'm not tempted to jump around and create problems. But here, now let's hide it again. I'm again refining a bit of this cutout that then can be cut from the case. For the final part, I added like a bit of an overlay so it doesn't flap around here in the middle. The next two steps will be creating like some additional cutouts. So here you have the loudspeaker of the scanner and the USB port, the USB plug. Here I had to keep attention that I'm not creating the cutout perpendicular to this surface, but perpendicular to the XY plane, because as you can see, the cutout itself, or the port itself, is not angled to this surface. So I just create a fitting plane, then the cutout for speaker, because they are like angled to the surface. Whereas, as you can see, after creating cutout and the sketch for the USB port, it is oriented to the origin of the scanner. So it's here. It's just I use the automatic slotting feature again, but keep an eye on like creating roughly roughly consistent radii or fillets, but such small deviations like this 0.1 millimeter really won't be noticeable in the final part. So this is just cut out then. The last two steps here on the top for the two covers are two freeform surfaces. So these two, they are used to prevent like the covers interfering with the handle on the top and on the bottom. I just used the surfaces and exported them into Fusion, and there used them as a cutting tool. As you can see, I'm first starting with let's go like this. It's automatic surface fitting. I just defined my target tolerance of roughly 0.1 millimeter, and then said the software, go, do your work. and I used a slight offset of the surface of 0.2 millimeters to ensure there is enough clearance. I did the same with the lower surface, or the lower freeform surface. And now we can even hide our top parts here, because I will be moving to the protective case for the grip. So this started with one big freeform that's symmetric to the YC plane. So you can create like free. So for example, if I now create a quick freeform surface here on top, or like here, and then let's duplicate this to the side. So it's roughly fitted to the surface. I can just enable symmetry. And now I can select one face and fit it on the symmetry plane. Of course, the resolution is now not enough, so it won't really fit. But as you can see, you're getting there you can get there quite fast. So with a bit of experience and feeling for the behavior, you're starting to get quite fast. Then I created a sketch for the cutout of the battery latch, or of the battery cover. So originally it uses two cylindrical batteries, and they are between the small hatch. It folds open a bit like on a regular camera. So I had to keep the space clear here. And I also wanted a lip to the front where this bottom part can rest on. Now I simply thicken the surfaces here. So at first my freeform surface, then I I first create a bottom plane that is used for closing the bottom side. And of course, with the cutout later, it will be opened again. Then I extrude the cutout, my front lip, and now I'm starting my trimming operations. So you could perform all of the trim steps in one trim, but it actually introduces a few problems. So you're getting a lot more intersections, gets harder to trim. So just do it in multiple trim steps. So this is the first trim, now the second trim, and now the third trim. As you can notice, at this step, I didn't combine these two surfaces together, because I first wanted to add all my fillets to this one before combining them. So this often makes filleting a bit easier if you're not too eager, or if you're not having like these very, very sharp intersections here that could cause problems. So as you can see, I first filleted this one and added fillets to my other part. So, and now the trimming step, where I just combined the parts and now created a very smooth intersection between the two, and a bit more filleting, of course. And what's now quite interesting, or what I now did, was I wanted this bottom part to have, because it's printed from TPU, to have like a friction fit to the grip. So there is not much mechanical interlock, so I wanted a friction fit. For this, I simply did a surface offset. So if you can look now, so this is the current state. So let's do it to 0.05 millimeters. You can see I'm basically spot on. And now I move the surface, and let's do it again. And as you can see, I'm now down roughly, 0.125 millimeters, I think, or 0.1 millimeter. So this created like the nice friction that's needed to hold it on and for it not to move around. So yeah, this is all the work I did in Quicksurface. And then I did a bit of like cleaning up. So if you can now remove them again to see the final part. So basically the main part is here, the power button. I had to cut out, and this additional protrusion here at the bottom. So the thin flap on the bottom, on the top. So if we look at this one, this fin flap wasn't stable enough because it's not supported. So I just added this protrusion. I hope you learned something, well, you could take some knowledge with you watching this video. I will, of course, put the link to the design in the description. So if you have a Rigil and want to reprint it or reproduce the design for your own scan, so keep in mind, I release my stuff under non-commercial license, so just selling the design is a no-go. But yeah, I hope you enjoyed, and I hope it was understandable. Now, as the parts are printed, I can attach them to the scanner. They are all like a snap fit on the scanner, and yeah, they're printed from TPU. It's the typical TPU. I printed it on my A1 mini scanner, and since they are snap fit, I can just like slide them on. You may have to start from one corner and then work around the scanner if you want to like already also use them. So the first part around the screen is attached. Now around the emitter section, there is like the side with the bulge to take this lip. So this one goes to the bottom, and you start from one side and then can just slide it on. If it's too loose for you, or you want this like thinner section to be more thoroughly attached, you can use some like reversible double-sided tape. And now the last part here around the bottom, and I actually haven't tried it out yet, but I guess it slides on quite nicely, just like this. I offset the inner surface by 0.1 millimeter, so it's a bit more snug. And now if I place the scanner on the table, it doesn't wobble around, or it's like more thoroughly attached, or it doesn't crash into the bottom section. So yeah, maybe, yeah, looks nice. All right. And the last thing we have to test if the battery hatch is still opening, and works like a charm. So I must say I'm quite content with how the whole design came out, and this simply gives me a bit more security when using the scanner.